Algebra 2 honor students, this is going to be stats day 11. I'm going to show you the day 9 answers. I know that yesterday's video had days 9 and 10. Day 10, I'd like you to send me your answers this week. So we'll go ahead and hold off on those answers for now. But day 9 was all about margin of error. So for the first two questions, you just have to calculate the margin of error, plus or minus 2 times that standard deviation. So really, I mean, it's a show your work, but there's not really a lot to do there, right? And number 3, as sample size increases, what happens to the margin of error? Well, if sample size goes up, margin of error definitely should decrease, because as the sample size increases, the variability and standard deviation decrease. So since the margin of error is a calculation based on standard deviation, if standard deviation goes down with sample size going up, so should the margin of error. And then it really was pretty repetitive on this homework, wasn't it? Margin of error for the next, actually, 4 questions on the back, 4, 5, 6, and 7, just calculating some margins of error. But finally, in number 7, we ask you about that plausible range. So the administration of the school will continue to study the feasibility of starting the day later if there's 70% support. According to the plausible range, we would see 70% in that interval. So it falls within the margin of error of the study. The challenge question at the bottom, if you were able to figure that out, to figure out the sample size needed to yield that margin of error 4%, what I thought about was that if the margin of error is 4%, that's plus or minus 2 times the standard deviation. So the standard deviation for this data has to be 0.02. So how do we calculate the standard deviation for sample proportions? It's P times Q over N. So an N is what I'm solving for. So I plugged in what I knew. I knew the standard deviation already. We know the P and Q values. And then solving that algebraically for N, I got that the sample would have to be 525, which kind of makes sense because that's about the graduating class of Fairport High School. So that at least is a number that made some sense in this context. Okay. All right, if we're good with that, this should be a really quick lesson for day 11. Day 11, what is it all about? It is about the topic random assignment. Okay, so we've really talked about a lot of things that involve randomly selecting samples and the important, I guess the importance of having randomization. Because if we have things that are random, we're going to reduce the bias. And we talked about that in the first part of our stats unit too. So what I want you to do is I would almost encourage you to read the studies on your own, hit pause, see what you can answer, see what you're maybe still a little bit unsure about the 2 studies, because I'm just going to roll through it right now, talk about some of the important things. And like I said, this should be a really quick lesson. So what is study A all about? Study A is about dog food. So we're designing this dog food to see if a new food against the food that the dog is eating, to see if it improves the dog's health. 30 older dogs were randomly assigned to either the new food group or the current food group. And then they're going to test to see whether or not it helped improve their health. For study B, we're talking about determining the difference in the mean number of text messages sent by 9th and 11th graders. So we took a random sample of 9th graders, asked them how many they sent in a day. Same thing for a random sample of 11th graders. Again, these key ideas with random sampling. We'll talk about what random assignment really helps us imply in just a few moments. That's pretty important when you're doing a study like this. The difference in the mean number of texts sent per day was determined. So out of the 2 studies, the only one that's an experiment is, hopefully you determined it to be study A. And the reason why it's an experiment is because that's the only one that it involved a treatment, right? In study B, we're just collecting information or data. So what is the treatment? It is the new food versus the current food that the dog is eating. What is the response variable in each study? So in each study, there is a response variable that was going to be measured. In study A, it was the health improvement of the dog. In study B, it was the text messages sent. Okay, so really to be a little bit more specific, in study B, it's the difference in the average number of texts that are sent between 9th graders and 11th graders. Okay, can the result of the studies be generalized to a certain population based on the samples used? What population can you generalize it to? All right, so this is kind of an important question. So if we want to take this information and then generalize it to an entire population, although it's an experiment, you cannot do that in A because the dogs were not randomly selected from a population. We were specifically looking at dogs in study A that were older dogs. So those dogs might have already had some health issues to begin with. So you have to be a little bit careful about generalizing it to an entire population of dogs. But in B, yes, you can generalize that to 9th and 11th graders at that school because of the random selection. So as far as generalizing to the population, that you have to be a little bit cautious about. Just because they were randomly assigned doesn't mean that you can generalize to the whole population. So all these answers come down to randomization. So let me kind of break down what the difference between random selection and random assignment are. What is random selection? It's randomly selecting a sample from the population of interest. So if you look at study B, the populations of interest with the 9th grade students and the 11th grade students. Okay, so we'll talk about some of the implications of random selection in just a few moments, whereas random assignment is randomly assigning subjects in an experiment to treatments. And that's an important part of experiments. But in that particular experiment, you weren't able to generalize to the population because of the population you started with. Okay, so I know that's, these words really start to sound really similar to one another. So it's important, I guess, to differentiate between random selection and random assignment. But moving on from there, let's go ahead and talk about some other conclusions that can be drawn. So at the top of the next page, it says, which study used random selection? And what does this allow us to do? So random selection was definitely used in study B. And what random selection does in that case is we can definitely generalize to the entire population of interest. Okay, so if you have random selection based on the results of your observations or the experiment, if it happened in an experiment, you can generalize to the entire population. And then which study can you conclude cause and effect and why? Remember, cause and effect is only a result of performing an experiment. So in study A, since this is an experiment with random assignment, we can use that to determine a cause and effect relationship. Okay, so it's important always within an experiment that you randomly select and randomly assign different, in this case, dogs, or it could be people, right? Whatever it is, random assignment is pretty important to make sure that the validity of your cause and effect in the end is that there's no bias involved there, okay? So in this chart below, it says fill in the table that summarizes the differences between the term random selection and random assignment. And I'll tell you, in experiments, you can have both, okay? So you can have random selection and random assignment. The experiment that we looked at did not specifically have random selection, but that would have made it even a stronger case to see whether or not we can generalize the effects of that experiment to the general population. Used in observational studies, we can have random selection because we just saw it with the text messages, but random assignment is not going to be present because there's no treatment involved. Okay, so random assignment is specific to an experiment only, so we're not going to see that in observational studies. So allows to generalize to the population. We saw a case where random assignment didn't necessarily mean that we can generalize to the general population. We can only do that in the case of random selection. Finally, the last case allows for cause and effect. Cause and effect is a result of random assignment, but not necessarily a direct result of random selection. Because remember, we had random selection in an observational study. Okay, but we can conclude that cause and effect there. And the reason why I said this was going to be such a short lesson today, guys, is because that is it. Now, if we were in class, we would have done a little bit more because there's a whole investigation that we were going to start by cutting out squares of paper, and you see that in the blank copies that are involved there. We were going to sort of do a little bit of an experiment with random assignment and draw some conclusions based off of that. But I think you got what you need from just looking at these two studies and now have the ability to go and try homework 11 at this point. If you have any questions about this quick lesson, you'll let me know, but we're not going to proceed. We don't really have the means to go through and try this experiment together. So that is it for random assignment. Have a lovely random rest of your day.